Hello students, in the last period we have seen about the work. Now we will discuss about energy. What is energy? We know to do the work we use energy in our body. That is, energy means the capacity of an object to perform a work is called energy. The capacity of an object to perform a work called as energy. Okay? The capacity of an object to perform a work is called energy. Now, in previous classes, we have seen the various forms of energy. For example, heat, light, solar energy, electrical energy, mechanical energy, chemical energy, and various forms of energy. Out of these, we have to learn about forms of mechanical energy. There are two forms of mechanical energy. One is kinetic energy and second is potential energy. There are two types of mechanical energy, kinetic energy and potential energy. Now, what is kinetic energy? Kinetic energy. Kinetic energy in short denoted by K, E. K for kinetic, E for energy. To define kinetic energy, we have to discuss about some examples. On carom board, when a striker hits the coin, then the coin moves away. So from this example, you can say that when the object in motion strike on the stationary object, then stationary object is in motion due to the motion of first object. This type of energy of object due to motion is called as kinetic energy. So, kinetic energy defined as energy of an object because of its motion. Energy of an object because of its motion called as kinetic energy. Due to kinetic energy, work is done on that object. So, kinetic energy gained by the object is equal to work done on object. So, kinetic energy is equal to work done on object. So, in this way, we have seen the what is energy and kinetic energy. Now, units of energy. Units of energy are same as the unit of work because energy is equal to work done. So, in SI system, unit of energy is joule and in CGS system, unit of energy is Earth. In this way, we have to write the definition of energy and types of energy, kinetic energy, potential energy, and what is meant by kinetic energy. Okay, now expression for kinetic energy. Expression for kinetic energy means we have to derive the equation of kinetic energy. Let an object of mass m, chart मध्ये लिहिते, mass m moving with initial velocity u and u is 0 at start, u initial velocity is 0. After time t, final velocity becomes v, and in this process acceleration is a and applied force F and displacement is s. Information chart मध्ये लिहिली. Let an object of mass m moves with initial velocity u when force F is applied, its velocity increases, and after time t, its final velocity becomes v, and displacement takes place through this process is s. And when the velocity increases, acceleration is formed. The acceleration is a. Now we have to derive the equation for kinetic energy. We know work W is equal to Fs. We know W is equal to F into S. वर्क इज इक्वल टू फोर्स इंटू डिस्प्लेसमेंट. आपण मागच्या व्हिडिओ मध्ये हे इक्वेशन बघितलंय. आता ह्या इक्वेशन मध्ये एफ आणि एस चे व्हॅल्यू आपल्याला ठेवायचे. वी ऑल्सो नो एफ इज इक्वल टू एम ए. कुठे बघितलंय आपण हे? एफ इज इक्वल टू एम ए फ्रॉम न्यूटन्स second law of motion. I am writing in short from Newton's second law of motion. आपण शिकलो force F is equal to ma. Similarly, from Newton's second equation, equations of motion शिकलो आपण 3 laws शिकलो, and 3 equations of motion. S equal to second equation of motion ut plus half at square. This is the Newton's second equation of motion. This equation is the equation from Newton's second law, and S is equal to ut plus half at square is the Newton's second equation of motion. Now here we put the value of u. Here u equal to 0. So putting u equal to 0, u into t means 0 into t 0 plus half at square. So s equal to half at square. याला म्हणू आपण इक्वेशन first. Now we have v is equal to u plus at. This is the first equation of motion. You know from first equation of motion. Now here also u equal to 0. So v equal to, putting u equal to 0, we will get v equal to 80. That is v equal to v square is equal to 80 square. We got v equal to 80 by taking square of both sides. We will get v square is equal to 80 square. Okay. Now putting this value in first equation. Now we have the value of f is equal to ma and s equal to half at square. Now put these two values in equation f and s in equation first. हे इक्वेशन्स कशाच्या आधारे लिहिले ते तुम्हाला समजले आहे. फ्रॉम सेकंड लॉ अँड फ्रॉम न्यूटन सेकंड इक्वेशन ऑफ मोशन. एवढं मी मिटवते. नाउ फ्रॉम इक्वेशन 1 W is equal to, put the value of f from this equation ma. Now put the value of s from this equation, equation 2, into half at square by multiplying half into m into a square and t square, that is half into m into at square, and we have the value of at square as v square. So by putting this value we will get w is equal to half m v स्क्वेअर, याला आपण इक्वेशन 4 नाव देऊ. अँड इथे लिहू फ्रॉम इक्वेशन 4. इक्वेशन 4 मध्ये आपल्याला मिळालं होतं v स्क्वेअर इज इक्वल टू 80 स्क्वेअर. ही व्हॅल्यू आपण 80 स्क्वेअरच्या जागी v स्क्वेअर ठेवलं तर आपल्याला मिळतं आहे w इज इक्वल टू हाफ mv square. But we have learned in the definition of kinetic energy gain equal to work done on the object, but Ke kinetic energy equal to W. We have seen in previous part. Now put the value of Ke in place of W. So equation will be Ke stands for kinetic energy. Kinetic energy is equal to half mv square. This is the equation of kinetic energy. Ke is equal to half mv square. In this way, you have to write all these expressions. Okay? Thank you.